Hello everyone, and welcome to this lecture in P8105, a course on data science. This is the first in a collection of 3 videos on building blocks, things like code and project organization, reproducibility, and version control. This video in particular is going to focus on getting up and running in R and RStudio, writing some code, and a basic workflow for project organization. I'm going to start by giving an overview to the material using some slides, and after that I'll do a screencast to demonstrate the material directly. Feel free to skip around in this video to the parts that you find most useful. I do encourage you to code along with me to get the most out of this. All the material is available at p8105.com. There are links in the description below. Awesome, let's get started. Okay, what I'm going to talk about now is getting started in R and in RStudio and some best practices for writing code and doing your own project organization. I'm going to talk first about what R is and why we're going to use R. R is a language that was designed for doing the kinds of statistical analysis, the kinds of interactive data work that comes up very often in doing data science. It was built on, it came after, chronologically, not alphabetically, came after the S language. S was designed originally to do the same kinds of things, and R is really built on that framework, but R was intentionally designed to be open source and open development, 2 things that I think really contributed to the success, the long-term success of R as a language. And so why is R good? I think that's a reasonable place to start if this is something that we're going to use. R, it turns out, is an extremely powerful language. And what I mean by that is that many of the things that you would want to do when you are doing data analysis, when you're doing data science, many of those things are possible in R, and often they're implemented in the first time in R as a language. And the reason for that is because R is extremely flexible. Although there is sort of a core R framework, one of the things that makes R so powerful is the ability for users, really anybody, to contribute to the kinds of things that somebody else can use by writing their own packages, and that extend the functionality of R in a lot of really important and powerful directions. There is an active community for R, and I think that includes both people who are writing packages for others to use, and also people who are using R, both base R and the collection of packages that exist out in the world. And that active community has become, especially in the last few years, a real asset. It's one of the things people want you to be successful in using R. There are online communities, there are message boards, there are supportive folks online and on Twitter and in a great many other places who are really trying to make R a welcoming and supportive place. It's helpful that R is free. That's especially in contrast to things like more traditional statistical languages like SAS and Stata and SPSS. It is also true, especially in the last few years, and I'll talk about this more in a minute, that RStudio has made R much better than it used to be and is now one of the best reasons to be using R. So why is R bad? At least up until the last few years ago, and certainly to an extent now, it is not always easy to learn. If you are coming at R without a lot of programming experience, it can be a challenge at the outset to think about how to write in a way that a computer will understand it, not in a way where you're sort of clicking on things and hoping to get the analysis that you want to get. I think it has gotten easier to learn R, and R has become more intuitive, especially the collection of packages that we're going to be focused on, but it's not always an easy thing to learn. I want to be clear about that at the outset. It's also true that R was not designed exactly for doing modern challenges. R was designed and it was created as a language 20 odd years ago, and 20 years ago data sets were very different than they are now. They tended to be smaller, they tended to be less complex, and so there are a lot of modern approaches to thinking about data and working with data, and even modern types of data that R wasn't originally designed for and hasn't always been the best at dealing with. It's also true that R is not always fast. That's one of the perennial complaints about R. For most things, it is fast enough, and for things where you really need speed, there are ways to work with other computing languages. Some of the things that are, I think, challenging, especially when you are getting started, is that there is not like a central support. In contrast to something like SAS, there is no company that is making R, and therefore there's no central support. There's not sort of a single place that you're going to go to get all of your questions answered and to get all of your sort of confirm that the things that have been written are correct. And so again, like there's no central coordination of support, of extensions and packages. There's no one who's sort of checking that the packages that you're using are doing the right thing. Now, all of these, I think, are criticisms of R that have a lot of easy rejoinders to, right? I think, as I said, there's an active community, and while there is no central support, there are now people who are engaged in making sure that people who have questions about how to use R can do that. There aren't sort of centrally coordinated packages, but there are a collection of folks who are really skilled at developing good packages, and those things I think are very much trustworthy. And so each of these things that says that R is bad, I think really should be taken with at least a little bit of grain of salt. None of these is such an issue that it's like I use R in spite of all of these things, and many times I don't even find them to be that big of a challenge. So why are we going to use R? I think it's recognized as one of the languages for doing data science, and that's for good reason. It was designed from the ground up for doing interactive data analysis, the kinds of things that statisticians have been doing for a long time. And that, I think, is in contrast to a language like Python, which is also, for good reason, recognized as a language for doing data science, but was originally designed as more of a programming language, as a scripting language, and was adapted for doing data science and data analysis. I think R, because of the design principles that were embedded at the outset, is a little bit more comfortable for me in doing the kinds of analyses that I tend to want to do. It's also, especially in the last few years, it's true that R has become very good for working with data. There are tools for data manipulation, data management, data tidying, processing, wrangling, however you want to refer to it, making plots, ensuring reproducibility. There are a lot of really useful tools in R, and I think those are good reasons to use it. And I say here also that extensions change how you can and should use R. Most of what we're going to see are things that have been contributed by others to the R framework to make it really a top-notch language for doing data science. Now, a lot of what I've been talking about is R, and I want to differentiate R from RStudio. RStudio is a separate organization. It is a company that develops an interactive framework and is closely aligned with a group of people who are developing the kinds of tools that make doing data analysis and data science easier in R. And this is, the sort of integration between the environment that we're going to use to interact with R and also the tools that we're going to be used. Here I'm thinking of things like the tidyverse, if you've heard of this. All of those things are contributions by RStudio that is distinct from R as a programming language, but RStudio really does make life an awful lot easier. So what is RStudio? As I said, like RStudio itself is a company that has released a variety of products. The one that we're going to be using the most is the integrated development environment. And if you've never heard of an IDE, that's completely fine. The basic description, or the way that I like to think of it is the place where you are going to do all of the data science things that you need to do in R. It's going to have places to write your code, to execute that code, to ensure that there's some reproducibility, to do version control, to do project organization. All of this is going to be in sort of like one self-contained nice little area, and that IDE, the integrated development environment, is one of the better reasons to use R. This is a picture from the book R for Data Science. It's now, I think, a little bit out of date, but it gives you an idea about what this looks like. So when you open RStudio, you're going to have a collection of panels available to you. There's going to be an editor where you can edit scripts or R Markdown documents. You can write these lines of code. There is a console where you execute lines of code. Again, R is a programming language where you write commands and then run those commands. So here we're writing commands in an editor and executing those commands in the console. And these 3 lines of code generate some output. The output that they show is here also in the RStudio IDE. Everything is sort of nicely contained. There's another panel up here that right now we're not going to worry too much about. There are other sort of tabs in some of these panels so that you can navigate to different elements. The basic thing, though, is that it's got the editor, it's got the console, it's got the output, it's got some other panels that is going to make working in R really, really seamless in a lot of ways. Now, I've been sort of talking about R and RStudio, but I also want to take a step back and just think about working with data in a very general sense. And I think the goal I hope that you have for yourself is that eventually you're going to be working on these big projects and you're going to have cool things that you're doing. There's going to be a lot of input data, there's going to be a lot of code, there's going to be a lot of outputs, and we're going to get there eventually. But to get there, I think it's important to instill some of the best practices, to instill some really good habits early on. And so one of the things that I strongly encourage you to start thinking about now is how to establish good habits when we're dealing with relatively smaller projects. To think about what are the basic principles of designing a data analysis? What are the habits that you want to get into so that later on, as projects become more complex, as things become a little bit more intertwined and connected, what are the things that you're going to want to have in place? What are the habits you're going to want to have in place later? And let's focus on developing those right now. So I'm going to start out, I'm going to talk a little bit about the code that you're going to write, and then I'm going to talk about how you organize code and how you organize projects, and why all of those things are important. So a couple of things, again, if you're new to programming, two big things to know right at the outset is that code is not case sensitive, and there isn't something that is going to do autocorrect for you. When I say code is not case sensitive, uppercase variables and lowercase variables are different from each other, and you're not going to know, or R is not going to know whether you mean something to be uppercase or lowercase, whether or not you mean something to be spelled correctly or not. It's going to be whatever you write is going to be the code that gets understood and interpreted by R. And so you do have to be careful in ways that maybe you're not used to. One of the things that might not seem to follow directly from that, but that I think kind of does, is that it's important to establish what is referred to as a naming convention. And the naming convention is the habit that you get into for naming variables and often files and folders and other things. What is the naming convention you're going to use? What is the process you're going to use to name various things? You can get these things that can be very, very complicated, but I think some of the ones that are the most popular is snake case. I guess this looks like a snake. I don't honestly see it, but this is referred to as snake case. Each word is separated by an underscore, and you don't want these to be too long, but this gives you an idea about what snake case looks like. Period case is a lot like snake case, but replaces the underscores with periods. Camel case, this makes a little bit more sense to me. I guess you have like the camel's humps, right? Okay. You can have lower and upper camel case depending on whether or not you start with a capital letter. I'm not making this up. You can also alternate capital and lower case, but please don't do this. So I think the convention that I have adopted, and this has become really popular in the last few years for reasons that are maybe interesting but not that interesting, is that snake case is really, I think, taken off as the most established, the most commonly used naming convention in R, and it's one that I'm going to encourage you to use. Variable names, and by extension file names, should match, roughly speaking, your regular expression skills. And if you don't know what regular expressions are, take that as a signal to mean that your names should be as simple as possible. They should be clear, they should be direct, they should be informative. You should be able to look at a variable or a file and know what's going on in there, and try to make things as simple and straightforward as possible. A last comment on code is that comments are going to save you a lot of headaches. And here I'm sort of thinking of comments as free text that explains what your code does. I guarantee you that you're going to think as you write code, you'll look at it and you'll say, this is crystal clear. Everyone will always understand what this code means. And then you'll put it away for an hour and you'll come back and have no idea what that code was intended to do. So comments, written text that says this is what this code is intended to do and why, that's going to save you a lot of headache. And very shortly we're going to switch gears a little bit. We're going to formalize this in the context of doing reproducibility and reports, where really you include both code and text at the same time. But for now, just sort of get used to the idea that you're going to want to have text that describes what your code is intended to do. This is not a joke. I have been in long meetings that focus on how we are going to name variables. Long meetings about how we're going to name variables. The best example that I ended up saw, I think it was a 10, 12, 14 page document that just described, here's how we're going to name all of the variables in this study. And that ended up being a lifesaver. So there you go. All right, so taking a step back from like the code that you're going to write is how you should think about the code that you generate in the first place. I think very often when people get started doing data analysis, they think of the outputs as the thing that they are working to produce. And by outputs, I mean the plot that you're making, or the table that you're getting, or the p-values that your model produces. You sort of think of those elements as the thing that you are intended to produce. But I really encourage you to adopt a different mindset, which is to think of the code that you write as the thing that you produce, and all of those outputs as just kind of transient things that, as long as you have the data in the code, you can always get back the things that you need to. So that mindset, I think, will encourage you to be careful about the code that you write, to sort of put emphasis on making sure that that's clear and complete, and that it really does reproduce all of the things that you need it to, and that gives you a sense of what it is you are working on. You're not working on the plot exactly, you're working on the code that produces that plot. The code that you write does matter as a means of communication. It is true, like that's the thing that you are going to produce, and you should view it as something that others will use. Maybe that others is going to be you, maybe that will be somebody else, but it is one of the most central ways that you communicate. On almost every project that I work on, at some point when we get down to it, somebody is going to ask to say, well, can I see the code that you use to implement this model, or can I see the code that you use to clean the data in this way? And the reason for that is that the code is the thing that actually does the work. And so if you need to understand completely how something was implemented, the code is often the best way to do it. A final perspective on code is that you should plan for mistakes. You're going to make mistakes. I make mistakes. Everybody makes mistakes. Making mistakes in itself is not a problem. What you should try to do when you have mistakes is fix it and be transparent about that. And you can, believe it or not, plan your code in a way that makes it possible to fix mistakes without sort of ruining your day. One of the worst feelings is when you discover that there's a bug on line 7 of your code out of 300 lines of code, and changing that one thing means that now every other line of code is broken. That is a terrible feeling, and I encourage you not to end up in that situation by writing code that sort of says, well, if I change this line of code, I can still rewrite the next one and the next, or rerun the next one and the next one and the next one without really having to make a lot of changes. And that, I think, will help both if you make mistakes on line 7, but also if things change as the project evolves. If it turns out you need to focus on one subgroup, or the collaborators that you're working with, somebody says, oh, it turns out we have a different data set that we needed to analyze in the first place, or we've updated, we've gotten some new information, here's a new version of the data set, can we just rerun this analysis? Plan for that and make sure that you can just sort of sit back, push a button, and regenerate all of those outputs in a quick and easy way. Now I want to sort of take a minute to think about how, again, we started with code, writing code, organizing code. Now I'm going to take a step back and think about organizing files. This is 2 examples of how a person might organize some files. The one on the left is, boy, just awful. And what I mean by that is you've got all data, final and I guess formatted. You have 3 versions of figures in PowerPoint slides for some reason. And then there are different versions of a paper, final with a couple of exclamation points, so maybe they meant it. You have the paper version 53, version 36 edits from somebody whose initials are KT, and that's, I guess, the 3rd version of that, and then some other stuff. That, I think, is not really a great way to organize the folder. And what I mean by that is if you open that folder up, it's going to take you a couple of minutes to figure out what is going on and what you actually need to find. On the right, there is a somewhat clearer version of this where you've got a directory, a folder that keeps track of the data. You've got a folder for drafts. You've got a folder for results. Presumably, there's another folder that has the code that operates on the data and produces those results. And the other thing is that the paper drafts now have a pretty clear naming convention. This is a little bit of a dated screenshot, but there's 2016-04-29. That's a date on which this draft was generated, and you can sort of keep track of that draft evolution over time. That's one way that you can use a naming convention to keep track of what's going on with this project. This is the kind of thing, if you see the kind of thing on the left, it is going eventually to drive you crazy. If you see the kind of thing on the right, you're going to be like, awesome, well-organized project. Let's just keep going, get to work. By now, I think like this Marie Kondo business has become a bit of a cliche, but there's some truth to it. Not just in like what is you're looking around your house and trying to decide whether a pair of socks sparks joy in your life. Also, when you're looking at your computer, you should think about, how do I need to organize things? How can I make my folders spark joy and bring me happiness? That I'm guessing sounds a little bit strange, but I think it is useful for sort of thinking about how you might organize things. Couple of related points. you are going to need to find all of the things that you have looked for previously, and you should make sure that you can find things easily. And one of the ways that I do that, again, is to make sure that projects are well organized, that the files in those projects are named reasonable things, that I'm not sort of putting special characters and exclamation points and spaces in my file names. I try to use snake case even for files. I think that makes life a little bit easier. Everything for a project is in the same place, and that project is in a place that makes sense. And you can think a little bit about what that project organization might look like. But for example, I would say data for a project lives in the same folder as the code for that project and the results for that project and whatever drafts come out of that project. And then that project might sit within a folder that has to do with a particular course, and that course might sit in a folder that has to do with a particular semester, and so on. But you should always make sure that everything is easy to find. And I think that's really a critical mindset to adopt when you are getting started on doing data science. Everything gets complicated eventually, so adopt habits now that are going to make it easy for you to stay organized as you start doing more data analysis kinds of things. And I really do hammer this point an awful lot because organization matters, and it's the kind of thing that you really only appreciate when you have gotten to a point when you spend hours or even days trying to reconstruct something that you did that you thought was obvious at a time, and now 6 months later you're trying to figure out what you had done and wasting an awful lot of time that just better project organization would have saved you from having to do. There's a quote that sort of floated around in a variety of formats. This is one that Carl Broman traced back to a tweet a while ago, but the idea is that your most frequent collaborator is you from 6 months ago, and you don't answer emails. And I think that's really, really true in my experience and in the experience of a lot of others. The person that I am setting up for success when I am organizing things is really just myself later on. And I often, and you will often, work on a project and then for whatever reason have to set it aside for a month or 2 or 3 or sometimes 6 and come back to it. And if you have set things up in a way that is clear and transparent and well organized, something that you can easily reconstruct, that's great. If everything is sort of scattered around and kind of a mess and you're trying to figure out, well, where is the code and where is the data and how did I make this plot and why did I make this plot in the first place, that's going to be something that's really difficult. Very relatedly, eventually someone other than you is going to need to reproduce your results. You're going to need to share what you have done. You're going to need to communicate that effectively. And the more organized you can be, the better off you're going to be when that happens. Okay, so what I'm going to do now is shift gears from this screencast, and I'm going to start doing from this slide presentation, I'm going to switch to a screencast, and we're going to start seeing how some of this works in practice. Awesome. All right. So I'm going to get started, and I am going to talk through how you can work in R and in RStudio. But before doing that, I'm going to reiterate some advice that came up in the slide presentation. And what I want to talk about in particular is thinking about and being deliberate about how you work with your computer. And I feel like that's the kind of thing that when you first hear it, you might think, I've been using computers since I was born. Obviously, I know how to work with a computer. But I think there is a certain mindset that you can adopt that is actually going to make things a little bit easier for you. And the mindset that I'm encouraging you to use is not like, well, this is the thing that I use to send emails and watch Netflix. It's how am I going to use a computer in a way that is going to make my life in doing data science and doing data analysis as easy and as seamless as possible. And so the kinds of things that I'm encouraging you to be deliberate about, like I've said, are how you organize things on your computer and how you name files and how you do project management, but also things like how much have you sort of internalized the use of hotkeys, and how much have you made it easy for you to navigate around on your machine. And there are a couple of things that I use that make my life a little bit easier, especially when it comes to sort of navigating around on my machine. What I like to use is called Alfred as a program launcher. I think on Windows there's another thing called Launchy. It's sort of similar to what's built in like Spotlight, but the thinking that I have is that if I can press the hotkeys, and it's on my machine, Option Space, and start typing RStudio and press enter, well then great. I don't have to think all that much. I don't have to engage in my mind about what I'm going to do if I want to launch RStudio, or if I want to launch a web browser or mail or do a variety of other tasks. And so that sort of thinking An analogy that I like to use when sort of thinking about how you're going to work with your machine is if you were going to be a chef in a kitchen. Usually successful chefs are not asking themselves as they are trying to cook, where did I leave the salt and where's the mixing bowl? If you have to stop and think about where things are, if you have to stop and think about how you're going to find the tools that you need, that distracts you from doing the thing that you're actually intended to do. If you're asking where the salt is, you're not focused on what you're actually trying to cook. And in the same way, if you're asking, where did I leave stuff and how do I launch this, and like what are the things that I need to do to write the code that I need to, if you're thinking about that part of things, then you're not spending as much of your cognitive process. You're not thinking as much about actually doing the stuff that you want to. So I encourage you, at first it's going to be difficult to be deliberate about those things, but before long you're going to find yourself working in a way that's a lot more efficient and a lot less distracted. And you're going to sort of gain fluency in the kinds of tools that you need in a way that makes it possible for you to create the things that you want to. And there's some really useful links on the p8105.com that I encourage you to read up on a little bit. All right, but I did, as you saw, launch RStudio, and before doing anything else, I'm going to talk a little bit about some of the preferences that I have for RStudio. And in particular, I'm going to go up to File, RStudio, sorry, Preferences. And I want to take a look at some of the things that are here. And I'm going to encourage you to adopt some of these same preferences as well. So here I have said, don't restore our data into workspace at startup, and never save our data on exit, and don't save my history and get rid of some of this other stuff. Those, I think, are some of the big ones. I'm also, I think, here in code, over in diagnostics, I'm going to encourage you to turn on show diagnostics for R. Diagnostics warn if variable is defined but not used. I'm going to ask you to turn some of these things on. The first two that deal with workspace and R data, again, a lot of this stuff might not make a lot of sense now. R, by default, will save everything that you have used previously, everything that was all the variables that you created and all the commands that you wrote. It will save all of those into the background, and the next time you start R, all of those things will repopulate. And you might think that that's a good thing, but I'm going to tell you that it's really not. If all of the stuff that you have done previously gets restored every time you restart R, well, you can start to use that as a crutch. And it will end up being the case that rather than making sure that all of your code is really nice and self-contained, that you're just sort of like starting R and closing it, and starting R and closing it. And so that crutch in the end will sort of give you a reason to not have really self-contained R scripts. And so I encourage you to turn both of those two things off. The diagnostics are a little bit different. When you start writing code, RStudio can give you little hints that say, you know, it would be cleaner if you put some extra spaces in here, or did you really mean to define this variable, or did you do some of this other stuff? And I'll talk more about that as we get started actually writing code, but for now, just sort of take my word for it and turn on some of those diagnostics. Okay, so what I'm going to do now, again, this should look familiar. What we have is here we have a big console. This is where we're going to execute commands. I've got this is the environment and history. We're not going to worry too much about that. And then I've got a collection of things for plots in the viewer window and a few other panels. Now there isn't right now an editor window. And so what I'm going to do is create a new script. You can either go to File, New File, R Script, but I know the hotkeys. It's Shift Command N, and I'm gonna create a new script using this. Now, right at the outset, first thing that I'm gonna do is create what's called a comment chunk. I'll talk a little bit more about this in a couple of minutes, and it looks like things that used to be things that used to be pound signs and are now hashtags. And what I'm going to write here is just a quick description. This is being written in August 2020. I'm Jeff Goldsmith, and this is my first R script. Fantastic. Now again, I'll talk a little bit more about that in a couple of minutes, but the idea at the beginning of this R script is, if nothing else, it should have some description of what it is and what I'm doing and why I'm doing it. So great, here we go. I've got an R script open, and I'm going to start trying to do some pretty simple things. Let's see what I can do. The first thing I'm going to do is 2 + 3, and I'm going to, right now, if I just press enter, nothing happens. Right? And you might be asking, well, why is nothing happening here? This is where I am writing commands, but this in the editor does not execute those commands. To execute those commands, I need these to be down on the command line. And so I've just copied and pasted, and that is one way to do things. It turns out that that's a very tedious way to do things. In RStudio, if I highlight this section of code or just leave my cursor on this line, and on a Mac press Command Return, on a Windows it's something similar to Command Return, this line of code will automatically get copy and pasted down to the window, down to the console, and executed. And so I could do something a little bit more complicated. Let's do 3 plus 7.1223 stuff. I'm going to take the log of this, and I'm going to raise it to the 0.465 power. Okay, and again, I've written this line, and I have put my cursor on this line, press Command Enter, and it copies that down onto the console and executes it. And I'm trusting that it's doing both of these two things correctly. 2 plus 3, I can double check, that is 5. Log of this, I assume this is right. And great, now I can do things like arithmetic and other kinds of things in R, and that I think is just, boy, really, really useful. Okay, so one of the things that I'm gonna do next is start thinking about the fact that it's nice to be able to, add numbers, but really what I would often end up like to be able to do is not just perform operations, but save the result of those operations. And so here I'm going to use what's called an assignment to say whatever 2 plus 3 is, put that into a variable that I am going to call x. And x is now going to store the result of that. It's going to be something that I can use elsewhere. So here I'm again going to put my cursor on this line and press Enter, and something strange has happened. I have run that line of code, but now instead of seeing the 5 as the output, it just says, okay, you ran that line of code. And the reason for that is that it is both computing 2 plus 3 and then saving the result of that into x. And if I want to double check that, I can type x and press Enter, and sure enough, it's gonna give me 5. I can put x up here and run it, and that's going to give me 5 as well. Okay. And here I'm going to save, let's say y is equal to the log of this business, and I can double check that y is what it is. And now I can do things like x plus y and get the sum of those two things, and sure enough, 5 plus 1.4 some stuff is 6.4 some stuff. Great. Everything is working exactly as I sort of intended it to. Okay. We can do a couple of things that are a little bit more complicated than this. If I wanted to, I could say that, let's leave x as it is, but I'm going to say that y now is equal to a collection of numbers, not just the log of this stuff. I'm going to do 1 and then 3 and then 6 and let's say 12. Okay. And now if I print y, if I ask what's in y, it's not just one number, it is a collection of numbers. I've got 4 here, numbers that are stored inside of that vector. And what I want you to see first is that you can have things that are more complicated than single numbers. In general, things that are saved into your environment, things that are variables that are stored by R can be quite complex, right? They can be entire data sets with very complicated structures that are being masked by something that you're calling a single name. The other thing that I want to draw your attention to is that in running this line of code, I have sort of gotten rid of what I had done previously. I have overwritten the previous value of y. So I started out by saying that y is equal to the log of this 3 some other stuff, and what I have now is that y is just this collection of numbers. And R is not going to stop and tell you, are you sure that you want to overwrite this thing? Are you sure that that's what you meant to do? R is going to take your word for it when you run a line of code, when you call a variable something. That's what you're going to get, and that's how it's going to work. It's maybe interesting to see that although x is a single number and y is a collection of 4, when you do x plus y, you get things that are generally reasonable here. And what I mean by that is that x is 5 and y is 1 and 3 and 6 and 12. And so when I add both of these, I get 5 added to each of those things. We're not going to worry too much now about the choice that R is making for how to combine things of different lengths, where one has a length 1 and one has length 4, but often it will try to do things that are generally reasonable. All right, so what I've done here, I want to be a little bit clear about. I'm going to add a comment that describes what this code is intended to do. And so we saw at the outset, I sort of used hashtags, pound signs, whatever you want to call them. I put those at the beginning of a line, and now I can write some text. So this code does variable assignments. And if I execute this line of code, nothing happens, right? If I try to run line of code that's just text, if I run this line of code, I'm going to get an error because R doesn't know what the words just and text are. But if you put the hashtags at the beginning, then you can say, ignore everything that's on this line of code. And that's one way to insert some text, to insert some descriptions, what are called comments, into the code that you're writing. Okay. So now I'm going to do another bit of coding. Let's take a look at data frames. Actually, before we get to data frames, I'm going to do something a little bit different. The next thing that I want to try to do is create a version of X that is drawn from a function that exists inside of R. And the function that I'm going to use is one that generates random numbers from a pre-specified distribution. And if you're not sure what a distribution is, that's not the main point of this video. Think of it as a way of generating numbers that sort of arise from something. And here I'm going to use RUnif for the random uniform. I'm going to get random numbers from a uniform. N tells me how many of those things that I want. So I'm going to say that N is equal to 20 here. Now, what this is going to do is generate 20 random numbers between 0 and 1. And if I run just this little bit of code, you can see each of those numbers. Here is 0.5, 0.7, 0.48, 0.27. They're not in order. And if I run this line of code again, I will get 20 different random numbers. If I run it again, I'll get 20 different random numbers. And again, I'm saving this into X. I'm doing the same thing that I had done previously and overwriting that prior value. And I could do some other kinds of manipulations here. Now, RUnif is often a little bit strange. It is what is a built-in function in R. I used one actually here also when I used the log, but this is a little bit different in that it's not just using some mathematical expression, it's actually generating numbers from R. And if you're not really sure what's going on, you can access what's called the help file for that function. And so I'm going to do question mark down here on the console, question mark RUnif, and it pulls up some information about this, the R documentation for that function. And again, that is pulled up inside of this RStudio IDE, so I can keep track of everything that's going on. This is the uniform distribution, information about the uniform distribution on an interval from min to max. So you can go either 0 to 1, you can go 1 to 7, you can go -3 to 3, whatever you want to. You can have a uniform distribution on a different domain. And you've got some information about what goes into this. So here, N is the number of observations that you'd like to have. Right? And I'm not going to spend a lot of time talking about this, either the uniform distribution or the help file for that. But if you see some of these functions being used and you're not real sure what they're doing, you can pull up the help file to go along with this. So log here, log computes logarithms, by default natural logarithms, and so on. Awesome, great. Okay, now that I have generated and stored X as this collection of random numbers, you can do other things with that vector. So here I can take the mean of X and it's 0.6. You can take the variance of X, it's 0.06. You could ask R, what are the mean and variance functions doing, by using question mark mean or question mark variance. Here it says that X is something that you're putting into this. And it's going to compute the trimmed arithmetic mean. It's going to compute the mean here, right? Again, we're not so concerned about what is the mean and what is the variance. More what I'm trying to say is that you can write code in R to do various things, and you can take advantage of existing functions inside of R to do it. All right. What I'm going to do now, I mentioned a minute ago, I'm going to switch gears a little bit and talk about data frames. Okay, before really getting into data frames, I'm going to load a package. Now, everything that I have done up to this point has been built into the base R framework. This is all stuff that comes directly with R. But as I said, some of the things that make R really powerful are the user-defined or extensions that have been defined by others in the community. To access those things, you first have to install packages. So you might have to run install package. Here I'm going to call the tidyverse. I have already installed this package, and I don't have to reinstall it just because I need to use it now. Once I have installed it onto my computer, it exists and I can use it every time that I want to. Since it has already been installed, I can load it using the library function. So here I'm using library tidyverse to load that package. Now, we're going to spend a lot of time in later videos / lectures talking about what the things inside of the tidyverse are. For now, just take my word for it that it's something that we need for this current example. What I'm going to do is create a data frame. Now, up in previous code, I've created some numbers and I've created some lists of numbers, some what we call vectors, where you have a sequence 1, 2, 3, 4, 1, 3, 6, 12, or a collection of 20 random variables. But often when you are really working with data, what you have is not just a list of numbers, you have what's more like a data rectangle. You have a collection of values where the columns tell you variable 1 and variable 2 and variable 3, and the rows tell you person 1, person 2, or observation 1, observation 2, observation 3, whatever it's going to be. So you end up with something that's a nice little data rectangle. These are not called data rectangles formally, they're called data frames, and there's a variant on those that are called tibbles. Again, we're going to spend a lot of time talking about data frames and tibbles in later videos / lectures, but for now I'm just going to create one real quick using the tibble function. So this tibble function is going to allow me to create a data frame, and that's what I'm going to do. So what I'm going to do is I'll create a vector of class numeric, meaning a collection of numbers, and I'm going to do the numbers between 1 and 4. So this might look a little bit strange. If I highlight just 1 to 4 and press enter, it will run just that little bit of code, and that gives me the integers 1, 2, 3, and 4. Okay. I'm also going to add to this a character vector. And so here I'm going to define this a little bit differently. I'm going to say my name is Jeff, and I'm putting each of those words in quotes so that R knows that this is a collection. This is like a word that I want R to know about. It's not a variable name. It's not something else. This is a word, and I am quoting it. Okay. And then the last thing that I'm going to do, let's create a vec type factor, and here I'm going to use something that looks kind of similar, and I'm going to say male, male, female, male. Okay. Now, there are a couple of things that are going on here. First, let me sort of run this and see what happens. If I execute this, it does give me this nice little data rectangle where I've got a column for the numeric variable, a column for the character variable, and a column for the factor variable. Now, you might very plausibly be asking, what is a number and what is a character and what is a factor? And again, we are going to get into a lot of those things in more detail. Briefly, a number is a number. Hopefully that's pretty straightforward. Factors are variables that take on a very small collection of values. So here, male, female are two versions, two values that this variable can take on, and R, in knowing that this is a factor, will understand that at least in this data set, those are the only two values that are allowed. And then characters can be any words or phrases or clauses that we want to have. Again, what exactly these are doing is not so important now, but it is helpful to know that in a data frame you can have numbers and characters and factors and other kinds of data, dates and times and other things, all sort of in a nice structured format. Now again, I haven't saved this as anything, so I am going to call it now example data frame is this tibble, and if I run this line of code, nothing happens, but I can check example data frame. Great, awesome. Okay, now there are a couple of other things that I want to point out as I'm sort of working through here. The first thing that I want to point out is what is called tabbed auto-completion. And so if I just start typing a word, RStudio will say the things that start with exa, maybe you mean the example function. I don't. Maybe you mean example df. I do, and I can tab and auto-complete that. And so that's going to work the way that I need it to. Okay, and maybe I'll make another point in just a couple of minutes. All right, so first though, here's the data frames. Here is the data frame that I'd like to create. And I'm going to try to make this a little bit more complicated. So let's make a data frame and some plots. Everybody loves plots. I love plots. I think everybody loves plots. All right, so I'm gonna create a slightly different data frame here. And the way that I'm going to create this data frame is going to look very similar to what I had done previously. I know that this is going to be a data frame that I'm going to use for plotting, so I'm going to call this my plot data frame. And I know that this is going to look like a tibble, or is going to be created using tibble. And so here's what I need to have. Now, the plot that I'd like to create, first I want to make like a histogram that just shows what the variable looks like. And then after that, I want to have two variables so that I can make a scatter plot of one sort of against the other. And so what I'm going to do here first, I'm going to say that the thing that eventually is going to sit on my x-axis is going to be called x. And I'm going to say that this is, let's call our norm. Our norm is very similar to our unif, but is going to create samples from the uniform distribution, or sorry, from the normal distribution rather than the uniform. And let's be ambitious. Let's make this 1,000. Let's get 1,000 draws from a normal distribution. And I'm going to set the standard deviation. Instead of 1, I'm going to set this to 0.5. I did say that I want to have two variables, and to make things interesting, I'm going to say that y is equal to 1 plus 2 times x, and I'm going to put some noise on top of this also. So the noise that I'm going to use is also going to come from a normal distribution, and I need to have 1,000 of those random variables as well, or 1,000 of those random draws. All right, so if I take this plot df and I want to take a look at it, I can print out, by default R here, with the things that we have done up to this point, is going to spit out only the first 10 rows. It's going to tell me that there are 990 more. That's great. I've got now 1,000 observations. And I can see X is some random numbers and Y maybe is something that looks like this. All right, now we are, again, a lot of the stuff that we're doing today is going to be stuff that we spend a lot more time talking about shortly, so don't worry too much about how to actually make this plot. But the framework that we're going to use for making plots is going to be ggplot. And ggplot is going to ask us for a variety of things. The first thing that it's going to want to know is what data set am I trying to plot? And the second thing that it's going to want to know is what do I put on the x-axis? And so here I'm saying, put the x variable on the x-axis and draw that variable from the plot data frame. Again, this doesn't have to make a ton of sense right now. Now it's also going to say, what kind of a plot do you want to draw? And what I want to draw is a geom histogram. What I want to draw is a histogram of this data set. And so if I run this bit of code, it's going to spit out a message that says I'm creating a histogram with 30 bins. And if I take a look again at the output of this line of code, I get this nice, tidy little histogram. And sort of sitting over here, it looks, if you don't know, this looks about like a normal distribution, right? And the numbers are going from about -1.5 to about 1.5. And I feel like that's pretty good. I'm pretty happy with this. Okay, I do also want to try something else, so I'm going to make another plot. Same kind of an idea. I have to tell ggplot what data set, and then I have to tell it what am I going to put on the x-axis, and what am I going to put now on the y-axis also, and then what kind of a plot do I want to use. And I want to use geom point. What I'd like to have is one point on an x and y, 1 point for each of the 1,000 in my data set. And so if I run this line of code, then I get something that looks like the following. Okay, so this is, I think this is pretty neat. I'm going to sort of tinker around for just a minute. I could do, for example, if I wanted this to be a little bit more complicated, what if I wanted to have y as a quadratic variable, and let's say y as a quadratic variable is 1 plus 2 times x minus 3 times x squared. My math here is getting fancy. And I'm still going to add on some random noise here. R norm size 1000. And then I'm going to create another version of this. See, I'm not going to create another version. I'm just going to update and say, what do I want to put on the y-axis is y quadratic. And let me run all of this again to create a data set that includes this. I guess I can skip the histogram, so I will. And then let me make this plot and see, do I get something? Yeah, looks like a nice quadratic variable here. Now there are a couple of other things that I can do in RStudio. It's keeping track of all of the plots that I've made, so I can look back at some of the things that I had seen previously. I can zoom here if I wanted this plot to be a little bit bigger. You can export into an extra window and sort of take a look in a bit more detail. That does turn out to be helpful in a couple of cases. I guess while I'm thinking about it, I'm also going to draw your attention now to this environment window. Hopefully my face isn't like fully covering the environment window. But what I have here is a listing of all of the things that R knows about. R knows about this X vector that I created. It knows about the Y vector that I created. It knows about the example data frame, and it knows about the plot data frame. And if I type any of those on the console in the command line, I can get those back. If I typed capital X for whatever reason, it's going to say that's not an object that we know about. We have not yet created a variable called X, and it's going to say there's an error. We can't find this. So again, there are things that I have created, and R is going to be case sensitive about these things. Okay, now what I've sort of been doing up to this point is just writing code as I go, and what I'm going to do now is actually try to organize this a little bit into some scripts, and I'm going to get rid of this quadratic business. That's not something that I really need right now. What I am going to try to do though is create, and this is a little bit artificial just to sort of drive home the point of having things that are self-contained and clear. What I'm going to do is create one script that does this kind of variable assignment and exploration, and another script that does data frames and plotting. So I've already got one script open here, and I'm going to create a second script, and copy and pasting is often your friend. So here I'm going to say, this is not my first script, this is my second R script, and this is for data frames and plots. Okay. And what I'm going to take out of this script is all of the code that was used for doing data frames. I'm going to put this over here. Okay, let me not save this quite yet. So what I've got now is a first script that does variable assignments, and a second script that does data frames. And there are a couple of things that I sort of want to think a little bit about as I'm doing this. The first is sort of the best practices that I've encoded in doing this. And the best practices that I've encoded in doing this is first that I have some information about what the script is intended to do at the beginning of each of these, so I can open it up and understand what's going on. I have at least some comments here. Let me sort of see, let me add a comment here just to be clear. First example data frame. And I've got comments here explaining what these lines of code are intended to do. I've got some code here that's doing also, I've got some comments that's explaining what's going on in the code here. Both of those I think are a little bit clear. In places where it matters, I have been pretty consistent about using a naming convention. I'm using snake case everywhere. I'm doing other things that are helpful. If something is a data frame, I'm putting that little suffix at the end to say this is a data frame, it's my example data frame, here's another data frame, it's my plot data frame. Inside of my data frames I have descriptive variable names. I have a vector that's numeric, I have a vector that's a character, I have a vector that's a factor. Each of these hopefully is pretty self-explanatory to me and to others. X and Y are tough as variable names. Here I'm using, often I discourage you from using X and Y. I think it's really easy to forget what these things are. But here what I'm using is an X and a Y because I knew eventually I was going to make a plot of Y versus X. And so in that sense, I think it makes a little bit of sense. The other thing that I'm doing is I think a little bit less clear right now, but I mentioned at the outset that you should turn on diagnostics. And what those diagnostics are doing in the background is checking that the code that I'm writing is maybe clear to somebody else. And the structure that I'm using, again, I think is something that takes a little bit of time to appreciate, but I'm doing things like making sure that I have a space on both sides of this equal sign and that I've indented these lines of code so that you know, for example, that these lines of code all exist inside of the Tibble function. If I start getting rid of some of these things, let me just sort of stop here and get rid of this, some of these white spaces. The code is exactly the same. I want to be clear about that. There's nothing that is different about this than what I just wrote. All of this is the same. And if I run these lines of code, it's going to do the same thing, and it's going to export the same results. The thing that's different is just how easy it is for somebody else to read what's going on. And I'm a little bit perplexed. I think I have the diagnostics on. Often R will tell you, you probably meant to put some white space in some of these things. But it's not telling me that right now for reasons that I don't entirely understand. But I like the structure that I'm using to make sure that my code is clear by using things like white space, by using things like spaces around the equal sign and other things like this should make your code a little bit easier to read. Now the next thing that I'm going to do, I guess to sort of finish that thought, there are useful style guides for how you might write your code. As a general rule, if you sort of try, at least for now when you're getting started, write your code kind of the way that I'm writing my code. It'll help. If you want some more information about that, you can take a look. I think we can look at RStudio style guide. Maybe the second one is the right one. The style guide from Advanced R, and it's got things like what you should name your files and what you should name your objects. And like this joke that I made, there are only two hard things in computer science: cache invalidation, that is hard, and naming things. Naming things is a hard problem. People spend a lot of time arguing about it, but they also encourage you to use snake case and clear variable names so that everybody knows what's going on. Okay. Also here in syntax, put white spaces around things, put spaces in other places, indent if you're going to indent something. I think all of that makes sense. Okay. All right, great. So then I've got these two scripts, and the next thing that I'm going to try to do is think about whether or not they have accomplished what I want them to, in the sense of making sure that everything is self-contained, right? I started out saying you should write scripts so that if you need to reproduce everything again, you can do that. And I'm not going to worry so much about reproducing this, but I want to ask myself, like, is my script self-contained to the extent that it will work the way that I need it to, right? And there are a couple of ways that you can check this. The first is by deleting all of the variables in your data set and then trying to recreate them without an error. And that's one thing that you can do if you type, for example, rm for remove, and you say the list of everything that you want to remove is ls, that lists everything in your environment and it gets rid of everything. I'm going to encourage you not to do that so much. I prefer to go to session and restart R. Restarting R will both clear the environment, and it will also unload any packages that you had. It will make sure that you have all of the dependencies in place. It's a little bit more formal of a way to do it. So I've restarted R and my environment is empty, and I'm going to try to recreate the plots that I made a second ago. And I want you to stop, if you're sort of following along, think about whether or not I have been successful in creating some standalone plots. I'm going to pause while you're thinking. Do you think it worked? Okay, so let's check. I can run this. Does that work? Yes, I can reinstall my package. I can get the example data frame, and the example data frame looks like it's supposed to look. So far, so good. I can create my plot data frame, and I can create my histogram, and then, oh no, I can't. I've done something. I did something, right? Now what I did, or how I know I did something wrong, is that when I ran this line of code, I didn't get a plot. And the other thing that it says is that there's an error in this thing, object y quad not found. Now, if you sort of remember, I took a brief digression to create a new variable in my plot data frame that was a quadratic version of this, and then I ran this and I changed a line of code here, and I went back and I changed something here, right? And I could have done similar things if I had been trying to edit my function on the command line. If I had been writing code in the console and changing things around here, like there are ways that mistakes like this creep into the code that you have written, right? So the reason, again, that it is helpful both to think about the R script as the piece that is important, and also the reason that it is important to periodically check that it is working the way that you want to, is that it is entirely possible for mistakes to creep into the code that you have written without you sort of being aware of it. And I gotta say, it is really frustrating to spend 4 hours working on something and then restart R and find out that that code doesn't work because 3.5 hours ago you scribbled some code into the console, and it sort of now all of your code has depended on that and you don't really remember what you did. So again, be careful as you're writing code and make sure that things are self-contained and everything's working the way that you want to. Okay. The next thing that I am going to point out, though, is that I've got these two scripts and now I need to save them somewhere. And the place that I'm going to save them is in their own dedicated folder. I'm going to say that this really is the time that I want to like, I've got two scripts. They are both related to the same project. I want them to be in the same place. And so the place that for now I'm going to put them is on my desktop. And I'm going to call this, what am I going to call this? Building blocks. And that's probably a pretty small font, but if you're looking at it, and actually it's probably right behind my face, so I'm going to move it to over here. Building blocks is written in snake case, and it's got right now nothing inside of it, and that's what I'm gonna fix. So I'm going to save both of these in my desktop in building blocks, and I'm going to give them names. Let's call this script assignment, and let's call this one script Dataframes. And now I've got both of these scripts saved in the same place and everything is nice. Okay, now I'm actually going to take this one step further, and I'm going to encourage you, now that I have a directory, now that I've got a folder on my computer that is relevant to this project, relevant to this work, I'm actually going to take a step further, and I'm going to put into that directory what's called an R project. I'm going to create an R project out of that directory. And so this is a little bit strange, but I'm going to go to File, New Project. Takes a minute. This is an existing directory, one that I've already created, and I need to find where it is. It's on my desktop and it's building blocks, and I'm going to open this and I'm going to create this project. And it takes a second and it restarts, and it looks like nothing really has changed. In fact, I'm going to quit and I'm going to reopen this whole thing. So here's building blocks. One thing that has changed is that there's this file with a weird extension called buildingblocks.rproject, now just floating around in that file. And if I double click this, the R project file, what's going to happen is sort of interesting. It's going to open RStudio and it's going to look very similar, but now listed under the files, it's going to have here everything that is relevant to that directory. It's got something up here that indicates that it knows which project it's working in, and everything is sort of nicely organized. Now, there are some other things that it turns out are helpful. When I start this R project, R is going to know, this is a sort of a tough thing to explain. When I start this project, R is going to know that I am sitting inside of this folder, right? We're gonna, at some point, have a more lengthy discussion about working directories and paths on your computer, but the short version is every directory on your computer lives in a particular spot. And if you want either to open things from that directory or you want to save something into that directory, you have to be able to tell your computer where that is. And right now, by opening this R project, RStudio knows that this is the folder that I'm sitting in. It knows that this is where everything is sort of coming from. And so I can do things that are a little bit handy here. So one thing that I might want to do is, let me rerun all of this code. Here I'm gonna, run everything. Nope. I'm gonna highlight everything and just press enter to run it. One thing that I might want to do is actually save that plot, right? If I'm thinking of the code as producing a plot, as producing some deliverable, this is the plot maybe that I want to produce. And so I'm going to save this using a function called ggsave, and I'm going to call this my scatterplot.pdf save it as a PDF. I'm going to say I want the height here to be 4, and let's say the width to be 4 also. And now, although I am not telling RStudio where to save this, right now, because I am using an R project, RStudio knows, well, I'm sort of sitting in this folder and that's where everything should go. And I'm going to press enter. And if I check out, let me see if I can find it. Here we go. Now inside of this folder, I actually do have that scatter plot, and it's been exported right here. Again, there's a lot here that you're probably wondering, well, why is that all our projects do? Is that it? And no, that's not it. It's probably more helpful that that's something that our projects do than you realize, but we're going to find some other things that our projects do that is useful in other ways. Now, for now, I'm going to encourage you mostly to adopt that as a habit. And in particular, when I say adopt as a habit, I mean think of a particular kind of a workflow that you might have for doing data analysis. And that workflow is the following. Have a directory on your computer. Mine's on my desktop. It would probably get moved. But have a directory on your computer that you can find quickly and easily that's going to hold all of the code that you want to write, all of the data that you need to have, all of the results that you need to produce. Make sure that everything is in that directory. Make sure that that directory is an R project. And then as you're working through, as you edit your code, as you change some things, make sure every now and then that you can restart the session that you're working in and reproduce all of the results that you need to. And starting that habit early on is going to make your life a lot easier. Okay, and I think with that, I'm going to wrap up this video. Thanks for paying attention, and see you next time.